right, we're going to start with a grade sheet. Some of you actually printed out the grade sheet, and that's fine. And some of you made the table that I showed you in a video earlier to make, and this should be on page 1 of your journal, should be your grade sheet. We add to the grade sheet throughout the 6 weeks, and then it does become a grade at the first grade of your next 6 weeks. So be sure you're keeping up with it. So we are adding 5 things. So number 1 is your team's assignment, your calculator assignment, your journal, warm-up 831, and your 7th grade review questions. Now 7th grade review questions have not been given back to you yet. And your warm-up, I will be sending you can go ahead and add it up if you want to, but I'll be sending those out to you, what you made on them. Teams and calculator and journal assignments should be in your assignments tab, but I might send them out in a message also because that might be easier for y'all to check on. So go ahead and write these down on the daily column. We haven't had a major grade yet. All right, if you need to keep getting that down, push pause and then push play when you're finished. All right, so review real quick from our last lesson, because it has been a while, is we talked about square roots. Now, square root is finding out what times what is going to give me that number. So, for example, what we did is the square root of 25 is 5 times 5. Now, that something cannot have a decimal. It has to be a whole number. So, 5 times 5 is 25. And the square root of 25, which we did not talk about, but will be on your vocab list this week, is called a perfect square because it makes a perfect square. All right? So we looked at some perfect squares. Square root of 144 is 12. It does not have a decimal after it. Square root of 81 is 9. That's a perfect square. Negative square root of 25. Square root of 25 is a perfect square. And here are some non-perfect squares, because if I actually work that out on a calculator, it's going to be a decimal. All right, so that was a quick review. If you didn't get all those notes, the video is still up on how to do it. If not, you're always welcome to go to my YouTube channel where all of these videos are posted on YouTube also. All right, so we're on page 4 today. All right, we're going to be on page 4. You should have your journal pages numbered. These are the 2 pages that in-class people are getting that are also attached in the assignments for you. If you want to print them out, you don't have to. I've had lots of questions asking me, how do I get the notes if I don't have a printer? And my answer is you handwrite them just like we're doing in this video. So be sure you're watching the videos. You're going to have trouble getting the notes if you don't. All right, so we're going to start with our types of numbers. And I'm going to slide this over so I can write on this. All right, so our first type of number are irrational numbers. So we're going to start with the definition. Irrational. These are numbers that cannot be put into a fraction. These are numbers that cannot be put into the fraction. So IR in front of a word means not, and rational numbers can be put in the fraction, which we're going to be looking at in just a little bit. But these are numbers that cannot be put into a fraction. Okay, and so a couple of notes about that when it comes to decimals. Decimals don't terminate. Or repeat. They do neither of those. Okay? This is going to include all perfect squares. Oh, sorry, all square roots. Oh, sorry. Except perfect squares. I'll say that again as soon as I get it written. All square roots except perfect squares. I'm sorry, that's kind of off the page. If you need to pause it there to get the definition, you may pause and then push play when you're done. All right, so irrational numbers. So I'm going to box that word. All right, we're going to look at some examples. So examples may be pi. Pi does not repeat, and it does not stop. It does not terminate. We also have square root of 30, because that is not a perfect square. We have square root of 5, because again, it is not a perfect square. All right, so our next one is rational numbers. Box it. And rational numbers are any number that can be written as a fraction. This includes terminating and repeating decimals. If something is rational, it cannot be irrational. Okay? They cannot be those two sets at the same time. So an example of rational number may be 3/4. That is a fraction. Or 0.6 repeating. Or negative decimal 3. Or negative 8. Or 5. Those are all examples of rational numbers. All right, if you need a pause, pause and push play when you're done. Integers. Now, I do want to remind you, you need to write your notes exactly as I write them, because when it comes to that journal test, you're going to want these exactly. Integers will include our whole numbers and their opposites. Now, in class, when we go over this, we actually start from the bottom up. But because I wanted to make sure you had enough space to write, we didn't do that. This is going to include no decimals at all and no fractions. All right, some examples would be, I'm going to put dot, 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 -2, -1, 0, 1, 2, dot, dot, dot. Now that dot, dot, dot means it keeps on going forever. And I put it before it because it keeps on going forever into my negatives, but it also keeps on going forever into my positives. All right, our next category is whole numbers. Again, I'm going to box it. This is our counting numbers plus 0. Now this should sound familiar because you do the same vocab words in 6th and 7th grade math. We each year add to it. So this year, irrational should be the only word that's new. Some of you may not remember last year, but that's okay. So we have no negatives in this category, no decimals, and no fractions. So examples are 0, 1, 2, 3, dot, dot, dot. Now don't put my dot, dot, dots in front because there are no negatives in this. All right, and our last category is called natural numbers. You will also see it called counting numbers. You see it both ways, so we're going to learn it both ways. Counting numbers, is what you see more in younger grades, what it's called. And then natural numbers, I've seen it used more in upper grades. So honestly, high school, you might see more of these called natural numbers than you see them called counting numbers. These are numbers we count with. Numbers we count with. There's no zero. There's no fractions. There's no decimals. And no negatives. And this is after the examples. That's all that's going on this side. So if you're like, I'm running out of room. Yeah, you should be. Well, I write really, really big, so you might not be. All right, so counting numbers. So actually what we count with. So if I'm going to count the students in my class, I'm not going to start with 0. I'm going to start with 1. So the only difference between natural numbers and whole numbers is the 0. That is the only difference. All right. So we're also looking at a Venn diagram. So we're going to do it on the left side. We're still on page 4. We've just moved to the left. And I want you to pause it, and I want you to draw this Venn diagram on your page. So you should have paused it and pushed play when you were ready, when you've drawn this on that page. It's going to take up the whole page if you want to. This is where we're going to list some different examples of our types of numbers. So we're going to start at the bottom with our natural and our counting numbers. So we're going to start with maybe 10. Number 10 is, or 3. But I want to look at some different examples. Maybe like 14 over 2. Now you may say, but Miss Joel, you said no fractions. And that is true, no fractions. But what does 14 over 2 simplify to? 14 divided by 2 is 7, and 7 is a natural number. We can also say square root of 9. Also, square root of 9 is simplified to the number 3, which is a counting number. We count using the number 3. All right, so let's move on to whole. So I want to think of some numbers that are whole, but aren't already listed here. So I can put 0. But that's all. Now some of you may say, but Ms. Joel, in our list of numbers, we put 0, 1, 2, 3, and that is true. But when I look at whole numbers, I'm looking at everything inside that circle. I have already put the number 3 down here. If I stick it out here, then I'm saying it is not a counting number, but is a whole number. And that's not true. So I have to be careful. The only difference between these two are the 0. Integers. This is where we're going to move up to our negatives. We're still not going to have fractions. Sorry. But I do have some negatives. I can throw a negative square root in there. Negative square root of 64 because it simplifies to negative 8. Rational numbers. These are numbers that are fractions and decimals that when they're simplified are still a fraction or decimal, like 5/10, or decimal 7, or decimal 6 repeating. Sorry, I drew the line first. Negative 3/4, or negative 0.7 repeating. Those are all rational. Irrational. Now you notice that they are separated. And what I want you to do is take any color that you want. I don't care if you want to take a highlighter. I don't care. And I want you to separate that line just a little bit more. Put a color on each side. Because what this is going to do is I want you to see that there's a separation. That they don't have any numbers at all in common. Alright, so irrational numbers would be pi. Would be a square root that's not a perfect square, like square root of 6 or square root of 17. But also, we put that it can be decimals that don't terminate or don't repeat.